Happy Friday to all the grade 9 students, and thanks for watching the follow-up video to the second Reachback of this week. As we go through this, what you're asked to do is please have your original copy of your questions and your answers in front of you. And as we go through these answers, please make notes of anything you didn't do right, or you left blank, or you made mistakes in, and hopefully this will help you improve your numeracy. The first question comes from Chapter 1 on surface area and symmetry, and it talks about angle of rotation and order of rotation. And remember that when we talk about it, we talk about order of rotation is the number of times an image appears as itself as you rotate it 360 degrees. So if we take this image and I was to rotate it this many times, I would have the original, there's the original, there it appears as itself, and as I do this 360 degrees, that image would appear as itself 5 times. So in this case, if I take my 360, back here. Therefore, the order of rotation, in this particular case, the answer for that is 5. Because it appears as itself 5 times as you rotate it 360 degrees. So the second part of that question says, what's the angle of rotation? And the angle of rotation as a formula is defined as being taking 360 degrees, or one rotation, dividing it by the order of rotation, and that will give you your angle of rotation. So since the order of rotation of this figure is 5, if we take 360 and divide it by 5, we get 72. Now 72 degrees means that this shape is rotated 72 degrees before it appears as itself. So if I take that image again and rotate it to there, and this didn't work out quite as well as I wanted it to, but whatever. 72 degrees is rotated to its original form again. So the answer is 72 degrees. The second question comes from Chapter 2 on rational numbers. And by the way, if I go too fast, make sure you press pause, because sometimes my explanations are pretty quick and you need to press pause to copy things down. So solve without using a calculator, show all your work. So in the first Reachback, we had the square root of a proper, I think it was 9/25 or something like that. This one is a mixed fraction. So instead of using a mixed fraction here, in order to solve it without a calculator, you need to think about 4/25 as being its improper fraction. So 25 times 4 is 100, plus 21 is 121 over the original denominator of 25. And remember, the square root means what number times itself. So what fraction times itself is 121 over 25. The numerator is 11, because 11 times 11 is 121. The denominator is 5. So therefore, our answer is 11/5, right? So 11/5 is what the square root of 4 and 21/25 is. So if I take this and move it over here, because this is a decimal over here, and because this is a fraction over here, I have to make a decision. What do I want my work to be? Do I want it to be fractions, or do I want it to be decimals? Now, obviously, if given the option, you should always choose decimals, because it's so much easier to work with. So here, all I'm going to do is I'm going to say, well, 11/5 is equal to 2 1/5 as a mixed fraction, which is equivalent to 2 2/10 as an equivalent fraction where the denominator is base 10, which means 2 2/10 is 2 2/10. So if you think about that string, and if you're having difficulty with this, you should press pause and copy that whole string out. 11/5 is 2 1/5, which is equivalent to 2 2/10, which is equal to 2/2, or 2 2/10. So with that said, I'm going to take my 2 2/10 and replace it with 11/5, right? Put it right up there. And now I have a decimal question that's fairly easy to do without a calculator. And this would be, I have $2.20 because that's a positive 2.2, and I owe $1.80. So if I owe $1.80 and I have 220, the answer would be, I could pay off all my debt, and I'm left with 40 cents, or just positive 0.4. That's my answer. So that's your answer for the first question 2. Question 3, it says, using exponent laws, simplify this expression to a single power. Well, let's take one part at a time. We're going to start with this part right here, because that's an exponent to a power. And the rule is, when you have a exponent to a power, remember, 10 cubed to the exponent of 4 would be 10 cubed multiplied by itself 4 times, in which case we would take 10 and add all the exponents together, which would give us 10 to the 12. But an easier way for us to do that is to simply keep the base and multiply the exponents. That's our law for a power to an exponent, which means this first highlighted part is going to be 10 to the exponent of 12, divided by the rest of the stuff here. Oh, actually, if you said the brackets should be done first, I guess technically the other part is brackets as well. So the next thing we're going to do is the brackets, which is right here. And I'm going to simplify that. Of course, when multiplying powers that have the same base, you keep the base and you add the exponents. So this is going to be 10 to the 4 plus 2, which is going to be 10 to the exponent of 6 when I simplify those brackets over 10. I'm going to clean it up a little bit here. And once we have it to here, we're going to simplify that top part. When dividing powers with the same base, you keep your base of 12, take away 6, you subtract your exponents. You're going to end up with 10 to the exponent of 6 over 10. All right, when I do this part right here, take my highlighter, this part here. That's the work you do. You keep the base and subtract the exponents. And once we have it to this last step actually means 10 to the exponent of 6 divided by 10. Right? These are the same thing. It's 10 over 10 to the power of 6, or 10 exponent 6 over 10. Remember, if the power doesn't have an exponent, the exponent is really an unwritten 1. And since we're dividing, we're going to keep our base of 10 and subtract our exponents, giving us a final answer for this question of 10 to the exponent of 5. Okay, now if you wanted to write that in standard form, it would be a 1 with this many zeros, 5 zeros, and your answer would be 100,000. But it says express it as a power, so that's our answer. If you did this, you didn't read the instructions properly, but it is a correct answer. Question 4, adding and subtracting polynomials, what is the perimeter? So I said you could either use a formula or not. So the easiest way would be simply to take all of the sides, those two sides, plus this side is also x, and this side is also this. So we're going to add all the sides together. And when we add polynomials together, we simply gather like terms. The x's are like terms, so that's negative 4x plus a positive 2x is going to leave us with negative 2x when we simplify or gather like terms. And a positive 5 and a positive 5, which are constant terms, would give us a final answer of positive 10. Now we can't add them further than that because there are no more like terms, so therefore the perimeter of this rectangle is negative 2x plus 10. Question 5, it says find the equation for this. So in order to find the equation that shows the relationship between x and y, you need to make a table of values and put your ordered pairs down. The first ordered pair is this dot right here, which is 0 on the x and 7 on the y. This one here is 1 on the x and 5 on the y. This one here is 2 on the x and 3 on the y. And this one here is 3 on the x and 1 on the y. So now that we have our table made, we can look for the relationship between x and y. What I like to do is put down x and y, leaving space for a potential coefficient and a potential constant in your equation. Okay, so now that we have that written, we're going to say what is the difference in y. So the difference in y, it's going from 7 to 5 and from 5 to 3. So it's going down 2 each time. And over here it's going from 0 to 1 and 1 to 2. It's going up 1 each time. So we take the difference in y divided by the difference in x. The difference in y is negative 2. The difference in y or x is positive 1. Negative 2 divided by positive 1 is negative 2. And that negative 2 is the coefficient in your equation that matches the line. All right, I'm going to clean it up a bit here. Once you have your coefficient, your next job is to take any of the ordered pairs. I always like to take the first because it's usually the smallest of numbers, but 0 and 7. And I take them and I substitute 0 and 7 into my partial equations. I'm going to take this equation, bring it up over here. So if I take my x and substitute x for the 0, that's right here, and substitute the 7 for my y, which is over here, and I simplify this, negative 2 times 0 is 0. And since 0 does not equal 7, I need a constant term of plus 7 to balance the sides. And when I'm done, I have found my equation that matches that line. So every point on that line, including the ones in between the points and beyond the points, would match the equation, multiplying the x value by -2 and adding 7 to get your y. Question 6 asks you to find the area of this rectangle instead of the perimeter, and we know that area is equal to length times width. And since we have a monomial and a binomial, and it doesn't matter which one we choose to be length or width, it's always easy to choose your monomial as your length, multiplied by the binomial, which is your width. When we solve this, we need to use distributive property because we're multiplying a monomial by a binomial. And x times -2x is -2x squared. Now, why is that? I'll show you over here. So x multiplied by -2x is the same thing as x multiplied by -2 multiplied by x. X times x is x squared, and -2 stays by itself. The next part of our distributive property is x times +5, which is simply a +5x. And that is the area. And some people might think you could add those two together, but because they're not like terms, remember, in order for a like term to be a like term, it has to have the same base, which it does, but it also has to have the same exponent, which it doesn't. So we can't add those two terms together. Our area is -2x squared plus 5x. Question 7, solving linear relations. This one's a little bit easier than your last one. So in order to do this, we have variables on both sides. And I said it might be easier if you're having difficulty to draw it. So what I'm going to do here is I'm going to go back to grade 7 and grade 8 when we use scales. And I'm going to put 2 x's and a -5. And I'm going to put 10 x's and a +3 on this side. So if I interpret this equation as a model, that's what it would be. And when we think about algebraic equations, we know that whatever we do to one side of an equation, if we do the same thing to the other side, it maintains equality. So what I'm going to do here is effectively I'm going to take those 2 x's away. And if I take 2 x's off that side, I have to take off 2 x's from this side. Okay? And that should still be balanced because I did the same thing to both sides. Now numerically what that looked like is I subtracted 2x from this side and I subtracted 2x from this side. So in doing so, I left myself with -5 equals 8x plus 3. Okay? That's your first step. If you have an equation where there's variables on both sides, get rid of the variable on one side by applying opposite. Now that we have that, we have to acknowledge that the variable is on our right, and I have a coefficient of 8 and a constant of 3. So I'm going to get rid of my constant first by subtracting 3. Then get rid of my coefficient by dividing by 8. And I have the solution of x equals -1. All right, hopefully you got that one. And our last question comes from Chapter 9 on linear inequalities. I'll bring this line down here for a second. So when you have a linear inequality, the algebraic isolation is still the same. The only difference is if you multiply or divide by a negative value, you flip your inequality sign. So when I subtract 7 from both sides, just like I would if I was getting rid of my constant in an equation, I end up with 6x is less than -6. Divide both sides by my coefficient. And all values less than -1 would satisfy this inequality. So I'm going to put -1 here, 0 here, and -2 here. Now because it's less than and not less than and equal to, we know that we use an open boundary point. I'll use red here. An open boundary point. And all values less than -1 would extend down on this number line to infinity of any value that is less than, but not equal to, -1. Hopefully that helped you all. There is an enrichment question for those of you who need a little bit more challenge. Do try the enrichment question. I will be providing the answer to last week's today and giving you a new one. And make sure that you communicate with your math teacher. They appreciate all of the feedback you give them and all of the letters. And keep doing what you're doing.